Our universe is unfathomably vast and ancient, yet it too faces a final destiny. We are about to journey through 30 mind-bending theories on how it all might end, from a silent freeze to a violent rip. You will discover a complete spectrum of cosmic finales that will forever change how you see the night sky. We will uncover how a single quantum bubble could erase reality in an instant, and whether time itself can simply stop. Which ultimate fate for the cosmos feels the most profound to you? The cosmos is slowly running out of usable energy. This is the foundation of the first and perhaps most widely accepted theory for our universe's end, known as the Big Freeze or heat death. It begins with the relentless expansion of space, a force we now know is not slowing down but accelerating. Over trillions upon trillions of years, this expansion will pull galaxies ever farther apart. Existing stars will consume their nuclear fuel one by one, flaming out into white dwarfs, neutron stars, or black holes. No new stars will be born, as the vast clouds of gas and dust needed to form them become too spread out and dilute. The universe, once ablaze with the light of countless suns, will grow dimmer with each passing eon. Eventually, even the longest-lived stars, small red dwarfs, will flicker and die. What remains is a cosmic graveyard, a near-perfect vacuum scattered with stellar corpses and the slowly evaporating remnants of black holes. In this final state, the universe reaches what physicists call maximum entropy. This is a condition where all energy is uniformly spread out, like a cup of coffee that has cooled to room temperature. There are no hot spots or cold spots left, no energy gradients to drive any process, no possibility for motion or life. The temperature everywhere will approach absolute zero, the point where all atomic motion ceases. Time itself may become meaningless as there are no longer any events to mark its passage. The cosmos becomes a static, eternal, and profoundly silent darkness. This is not a dramatic explosion or a sudden collapse, but a slow, quiet fading into a permanent and universal winter. But the cold, silent fade of the Big Freeze is not the only possible finale. A dramatically different destiny awaits our cosmos if the force currently driving it apart should ever falter. This is the theory of the Big Crunch, a cosmic reversal so complete it would undo creation itself. Here, the universe's great expansion is not eternal. After reaching its maximum size, the relentless pull of gravity, the collective weight of all matter, would finally overcome the mysterious push of dark energy. The expansion would slow to a halt, and then the long, slow fall back inward would begin. Galaxies, pulled by an irresistible force, would start rushing toward each other. The sky, which has been growing emptier for eons, would begin to fill up again, the distances between celestial objects shrinking at an ever-increasing rate. The background temperature of the universe, now just a fraction of a degree above absolute zero, would begin to climb. At first, this reversal would be almost imperceptible, a gentle cosmic sigh. But as the collapse accelerates, the universe heats up. The scattered stellar remnants, the dead stars and black holes, are pulled together into an increasingly dense and violent soup. Galaxies merge in catastrophic collisions, their stars torn apart by tidal forces. Space itself becomes a furnace, with the temperature rising first to that of stellar surfaces, then to the core of stars, and finally beyond any comprehensible scale. All the universe's structure, every galaxy, every planet, every atom is erased. Everything is pulled toward a single point, a state of infinite density and temperature known as a singularity. It is the exact reverse of the Big Bang, a catastrophic implosion that compresses the entirety of reality back into a single, dimensionless point. This final moment would be the end of time and space as we know them. The universe would not just be destroyed, it would be uncreated, its entire history and future crushed out of existence in an instant. Could our expanding universe one day turn around and begin this fatal collapse, Or is this dramatic end already ruled out by the cosmos we observe, yet there is a third, even more violent possibility? What if the force tearing the cosmos apart does not fade or remain constant, but grows infinitely stronger? This is the theory of the Big Rip, a finale of pure, unbridled destruction. In this scenario, the mysterious dark energy accelerating the universe's expansion is not a steady influence, but a phantom force that intensifies over time. Imagine a spring that, instead of relaxing, becomes tighter and more powerful with every passing moment. Billions of years from now, this strengthening repulsion would first overcome the gravitational glue holding galaxy clusters together. These vast islands of stars would be flung into the ever-widening void, isolated and alone. But the destruction would not stop there. As the phantom force grows, it would next target the galaxies themselves. The same gravity that binds billions of stars into majestic spirals and ellipses would be overwhelmed. Each galaxy would be systematically shredded, its stars scattered into the darkness like dust in a hurricane. Our own Milky Way would be torn asunder, the Sun and its sister stars sent on lonely, divergent paths into the expanding emptiness. The solar system would be the next to go. The Sun's gravitational hold on its planets would be broken. Earth would be ripped from its orbit, cast adrift in a now black sky, and then, in the final, terrifying moments, the force would turn inward. The phantom energy would become so powerful that it would exceed the very forces that hold matter together. Planets and stars would be torn apart. The gravitational and nuclear forces that bind atoms into molecules and protons and neutrons into atomic nuclei would be defeated. In a final, instantaneous flash, every single atom in the universe would be violently dissociated. Every particle would be flung away from every other particle, moving so fast that they could never interact again. The universe would not end in cold or heat, but in a fundamental dissolution of reality itself, leaving behind nothing but an ever-expanding, perfectly empty and utterly featureless void. What if the universe's final collapse is not an end but a new beginning? This is the breathtaking premise of the Big Bounce, a theory that transforms the apocalyptic Big Crunch into a cosmic rebirth. In this cyclical model, the universe does not simply implode into a singularity and vanish. Instead, that moment of infinite density and heat becomes the seed for a new Big Bang. The violent contraction of one cosmos gives birth to the explosive expansion of the next. Our entire universe, with all its galaxies and stars, could be just one cycle in an endless, timeless loop of cosmic death and resurrection. Picture a cosmic heartbeat, a vast, rhythmic pulse where each contraction is a crunch and each expansion is a new bang. This idea elegantly sidesteps the troubling question of what came before the Big Bang. There was no before, only an endless sequence of universes, each one emerging from the ashes of its predecessor. Our own cosmos, with its specific physical laws and constants, might be the product of the conditions present at the moment of the last bounce. Perhaps the mysterious dark energy driving our expansion today is simply a leftover signature from that primordial rebound. This cyclical model offers a profound sense of continuity, suggesting that creation is an ongoing process without a true start or finish. Could it be that the universe has always been here, not as a single entity, but as an eternal phoenix, forever rising from its own ashes? The serene rhythm of a cyclical cosmos offers a comforting sense of eternity, but another theory suggests the ultimate end could be both instantaneous and utterly random. This is the idea of vacuum decay, a quantum threat that could erase reality without any warning. Our universe, according to modern physics, may not be in its most stable possible state. Think of space itself as a vast, tranquil valley, but this valley rests on a high plateau. This is a false vacuum, a state that seems stable and peaceful, but is not the absolute lowest energy state possible. Somewhere far below this plateau lies the true vacuum, the absolute bottom of the cosmic energy landscape. The problem with a false vacuum is its inherent instability. A random quantum event anywhere and at any time could create a tiny bubble of this true vacuum. This bubble would not be empty space, but a region where the fundamental laws of physics are completely different. The constants that govern reality, like the strength of gravity or nuclear forces, would be rewritten in an instant. This bubble would then expand in all directions at the speed of light. The wall of this expanding sphere would be a wave of total transformation. As it moves, it would not smash into planets and stars like a physical shock wave. It would be far more thorough. Upon contact, every single piece of matter would simply cease to exist in its current form. Atoms would instantly fall apart, their structures incompatible with the new, alien laws of physics. There would be no explosion, no sound, and no time to react. One moment, the universe exists as we know it. The next, a sphere of pure, unrecognizable physics is growing at the ultimate speed limit, converting everything it touches into something entirely new and almost certainly incapable of supporting life or any complex structure. Because it moves at light speed, you could never see it coming. The end of your world would be the first and last thing you experienced. This cosmic doomsday could be triggered 1 billion years from now, or it could have already started in some distant galaxy, its wave of annihilation already on its way. How do we know our reality is not perched precariously on the edge of such an irreversible collapse while the threat of vacuum decay is a cosmic gamble? Another theory suggests our entire universe is just one safe bet in an infinite cosmic casino. This is the concept of eternal inflation and the multiverse, an idea that redefines what an end to everything could even mean. Picture the greater cosmos not as a single entity, but as an endlessly bubbling cauldron of reality. Our own universe, with its Big Bang and subsequent expansion, is just one bubble that formed in this seething, primordial froth. The space between these bubbles is a realm of hyper-fast, eternal inflation, a state where space itself is expanding at an unimaginable rate. In this frenzied background, new universe bubbles are constantly nucleating at random, each one a new Big Bang event with its own unique set of physical laws and constants. Some of these baby universes might instantly collapse or become sterile voids. Others might be stillborn, with laws that prevent any complex structure from ever forming. But a fortunate few, like our own, will have the perfect, delicate balance needed for galaxies, stars, planets, and life to emerge. In this breathtaking picture, the ultimate fate of our single bubble becomes a local event, not a cosmic finale. Our universe may eventually face a big freeze, a big rip, or even a vacuum decay. But while our bubble is slowly darkening or being rewritten, an infinite number of other universes are being born in the greater multiverse beyond our observational horizon. The end of our story is merely a paragraph in an endless, ever-growing library of realities. This makes the very idea of a single, universal end almost irrelevant. How could everything end when an infinite number of new beginnings are constantly happening just beyond the veil of our own spacetime? From the cold equations of cosmic bubbles and multiverses, we turn inward to a theory that is as profound as it is unprovable. What if the universe is not just a collection of dead matter and energy, but is itself a conscious mind? This is the hypothesis of cosmic consciousness, a concept that blurs the line between physics and philosophy. Proponents of this idea suggest that the vast, interconnected network of galaxies, stars, and planets, operating through the fundamental laws of quantum mechanics and gravity, forms a system of unimaginable complexity. This system could be capable of a form of thought, a slow, vast cognition on a scale we cannot comprehend. In this view, every star is a neuron, every galaxy a lobe of a cosmic brain, and the entire observable universe is a single, thinking entity. The ultimate fate of such a universe would not be a mere physical end, but a metaphysical transformation. Perhaps the long-term evolution of the cosmos, its expansion and cooling, is not a journey toward death but a process of maturation. The final state of maximum entropy, the heat death we feared as a cold, silent end, could instead be a state of perfect, unified awareness. It would be a form of cosmic enlightenment where the universe, having experienced all possible states and forms of life, achieves a timeless, placid consciousness. All distinction between observer and observed would vanish. The cosmos would become a single, self-aware thought, contemplating its own existence for eternity. Alternatively, this universal mind might not be waiting for the end. It could be actively working toward a goal, a great awakening, or a transition to a different plane of reality entirely. The accelerating expansion, which seems like a force of destruction, might be a necessary step for this consciousness to shed its physical form and transcend into a state of pure energy or information. This is not a theory that can be tested with a telescope or a particle accelerator. It lives in the realm of speculation, a poetic and haunting answer to the mystery of our existence. It suggests that we are not just inhabitants of the universe, but are tiny, fleeting fragments of its vast, awakening mind. Is our own search for meaning and understanding merely the universe beginning to know itself? Our own consciousness may be a fleeting part of a universal mind, but what if the entire cosmos we perceive is just a shadow of a deeper reality? This is the startling premise of the holographic universe theory, an idea born from the complex mathematics of string theory and black hole physics. It suggests that our rich, three-dimensional reality, with its galaxies, stars, and our very selves, is not fundamental. Instead, it is a magnificent projection, a cosmic hologram, emanating from a two-dimensional surface that exists at the very boundary of our observable space. Think of it like a credit card hologram, where a flat, etched surface creates the stunning illusion of a three-dimensional image floating in space. In the cosmic version, the information needed to describe every particle, every force, and every event in our universe is actually encoded on this distant two-dimensional shell. Our experience of depth, of volume, of moving through a three-dimensional world is an incredibly convincing and complex illusion generated from this flat source. This leads to a profound question about the universe's ultimate fate. If our reality is a projection, then its end could take two radically different forms. In one scenario, the information that makes up our universe is permanently preserved on that two-dimensional boundary. Even after the last star winks out and the cosmos reaches a state of heat death, this cosmic hard drive would still hold the complete data of everything that ever was. The universe would be frozen, not just in energy, but in a state of perfect memory, its entire history etched onto a flat, timeless surface for eternity. The other possibility is far more abrupt. The projection itself could simply stop. The process that translates that two-dimensional data into our three-dimensional experience could falter and cease. It would be like a movie projector suddenly running out of film. The image of the cosmos would simply vanish. There would be no catastrophic collapse, no violent rip. One moment, reality exists in all its apparent depth and complexity. The next, the projection ends, and the three-dimensional universe winks out of existence, leaving only the silent, flat, encoded data behind. Is our vibrant cosmos merely a temporary and brilliant display, flickering into being from a simpler, flatter reality? Could our reality be nothing more than an advanced computer program? This is the startling proposal of the simulation hypothesis, a theory that our entire universe, from the most distant galaxy to your own conscious thoughts, is a digital construct. In this scenario, the cosmos is not a fundamental physical entity but a sophisticated simulation, perhaps created by a vastly more advanced civilization for purposes of research, entertainment, or historical preservation. Think of it like an open-world video game of unimaginable complexity, where every particle, every force of nature is governed by a flawless and consistent code running on some unfathomable computer. The laws of physics we have painstakingly discovered would not be fundamental truths, but merely the programmed rules of the simulation. This leads to a radically different set of possibilities for the universe's ultimate fate. The end would not come from within the physics of our cosmos, but from outside it. One possibility is a simple shutdown. The creators of the simulation, for reasons we cannot guess, might decide to simply turn it off. One moment, reality exists in all its richness. The next, there is nothing. No warning, no collapse, just an instantaneous and total cessation of existence, as if someone pulled the plug on a computer. Another, perhaps more unsettling, end would be a system failure. Even the most powerful computer has limits. The simulation could begin to suffer from processing overload or a critical error. From our perspective inside the program, this might manifest as the laws of physics beginning to break down. Gravity might flicker unpredictably, the speed of light could change, or random patches of space might simply cease to exist according to their own rules. The universe would not end with a bang or a whimper, but with a fatal system crash, or the end could be a reboot. The creators might decide to reset the entire program, wiping the slate clean to run the simulation again from the beginning, perhaps with slightly different initial conditions. Our entire history, every life lived and every star that ever shone would be erased, only to be potentially replayed in a new, slightly different version. This idea forces us to confront a profound question. If we are in a simulation, is our search for the universe's final fate ultimately meaningless because the true end lies not in the stars, but in the hands of a programmer we can never see? Even the most stable building blocks of reality may not be permanent. Deep within the heart of every atom, the protons that define the very substance of our world could be ticking time bombs. Current physics tells us protons are incredibly stable, with experimental data suggesting they last for at least 10 to the 34th years, a number so vast it defies comprehension. But many grand unified theories which attempt to merge the fundamental forces predict that over truly cosmic timescales, even protons will eventually decay. Imagine the fate of matter after the last stars have died. The universe is a dark, cold graveyard filled with the remnants of stars, black holes, and countless free-floating subatomic particles. In this near-absolute zero landscape, a single proton, part of a long-dead iron core from a forgotten star, spontaneously disintegrates. It does not break apart physically, but transforms, its energy converting into a burst of radiation, a faint ghost of light in an otherwise eternal night. This is not a fast process. It would take perhaps 10 to the 40 years for just half the protons in a given piece of matter to decay. But given enough time, this slow evaporation would be the final fate of all matter. Every planet, every asteroid, every speck of dust that was not already consumed by a black hole would gradually and silently turn to light. The stellar corpses, the white dwarfs and neutron stars that dot the darkness would not be spared. They would slowly dissolve, their immense mass bleeding away as pure energy. The universe would transition from a collection of solid objects to a thin, ever-expanding sea of radiation, a final, fading glow where atoms and molecules once existed. This ultimate dissolution raises a haunting question. If even the protons that make up our bodies are not eternal, does anything made of matter truly last forever? Or is everything we know destined to eventually return to pure, formless energy? But if protons themselves dissolve into light, what happens to the stage on which this final act plays out? We have been assuming that time is a constant river, flowing from a definite past toward an uncertain future. Yet some of the most profound ideas in physics suggest that time itself may not be a fundamental feature of reality, and its end would render our very concept of a cosmic finale meaningless. Time in our daily experience feels absolute and relentless, but when we look at the core equations governing the universe, from Einstein's relativity to quantum mechanics, time often appears as just another dimension, not so different from the three dimensions of space. In certain quantum gravity models, which attempt to unite the very large with the very small, the concept of a universal clock simply vanishes from the mathematics. The flow of time might be an emergent property, a collective illusion generated by the complex interactions of countless quantum events, much like the sensation of temperature emerges from the frantic motion of molecules. If this is true, then the end of the universe could be the moment this illusion finally breaks down. Picture the cosmos in its final state of heat death, a vast, uniform sea of particles and radiation at equilibrium. In this state, nothing ever changes. There are no energy differences, no processes, no events to mark the passage of time. In a universe where absolutely nothing happens, does the idea of a next moment have any meaning? Physicists argue that in such a perfect equilibrium, time would effectively cease to exist. There would be no before and no after, just a single, eternal, static snapshot. The universe would not be moving toward an end, it would have already arrived at a timeless state. This is not an event in time, but the end of time itself. The arrow of time, which points from order to disorder, would have reached its ultimate destination, and with its goal achieved, the arrow would simply vanish. How can something end if there is no time for the ending to happen in? The ultimate fate of all things might not be an event, but the quiet dissolution of the very container that makes events possible. The very dissolution of time presents the ultimate paradox for a conscious observer. In a universe destined for eternal, silent equilibrium, how could we possibly be here to witness its middle age? This bizarre contradiction leads to one of the most unsettling ideas in all of cosmology, the theory of Boltzmann brains. It proposes that in a cosmos that exists for an almost infinite duration, the most likely form of a conscious observer is not a product of billions of years of biological evolution on a stable planet, but a fleeting, random accident. Imagine the universe in its final state, a near-perfect void trillions upon trillions of years in the future. The temperature is uniform, just a fraction of a degree above absolute zero. In this vast, changeless sea, a random quantum fluctuation occurs. This is not just a tiny blip of energy, but an incredibly improbable event where particles spontaneously arrange themselves into a fully formed, self-aware brain, complete with a lifetime of false memories. This disembodied consciousness, a Boltzmann brain, would flicker into existence for just a moment, perhaps believing itself to be a human looking up at the stars, before the fluctuation subsides and it dissolves back into the random noise of the void. The statistical argument is chilling. Over an infinite timescale, the odds of such a random, brief fluctuation producing a single, conscious brain become vastly more probable than the incredibly complex and ordered process that led to our actual existence through cosmic and biological evolution. The universe does not need to form galaxies, stars, and planets over 13.8 billion years to produce you. It can simply assemble your consciousness and all its memories from the chaotic void in an instant. This forces a deeply troubling question. How can we be sure that we are not Boltzmann brains ourselves, momentary illusions that just popped into being, complete with a false but coherent history of a universe that does not truly exist in the way we remember it? The theory suggests that if the standard model of an eternal, cooling universe is correct, then the number of such random, disembodied observers should overwhelmingly outnumber the ordered biological ones. Our very act of observation, then, becomes the strongest evidence against the lonely, eternal future we have long predicted. Deep within the cold, dark future, long after the last proton has faded, the universe enters its final, dominant age. This is the era of black holes. All other structures are gone. The stellar corpses, the white dwarfs and neutron stars, have long since evaporated through proton decay, leaving behind only the most gravitationally powerful objects in existence. These black holes, ranging from the stellar mass to the supermassive behemoths at the centers of dead galaxies, are now the sole rulers of a nearly empty cosmos. They drift through an expanding void of unimaginable scale. their immense gravity the only significant force left in a universe approaching absolute stillness. But even their reign is not eternal. In a process as slow as it is inevitable, these cosmic titans are destined to fade away. Stephen Hawking theorized that black holes are not completely black. Due to weird quantum effects at the very edge of their event horizons, they slowly leak radiation. This Hawking radiation is a faint whisper of energy, a trickle of particles that escapes the black hole's grip. This process comes at a cost. To radiate this energy, the black hole must sacrifice a tiny amount of its own mass. For most of a black hole's life, this evaporation is negligible. A black hole with the mass of our Sun would take 10 to the 67 years to evaporate, a number so vast it dwarfs the current age of the universe. But given enough time, this slow leak becomes a torrent. As a black hole loses mass, it shrinks and its temperature inversely rises. A smaller, hotter black hole radiates energy away even faster. In its final moments, this evaporation accelerates dramatically. A black hole that has persisted for trillions of years will vanish in a sudden, final flash of gamma rays, a last brilliant shout in the eternal silence. One by one, across the cosmos, these final monuments to gravity will spark and disappear. The supermassive black holes, the last anchors of reality, will be the final ones to go, their demise marking the true end of structure in the universe. What remains is a cosmos so empty it defies description, a near-perfect vacuum where not even a black hole disturbs the perfect, featureless dark. Yet even after the black holes have evaporated, the story may not be over. A final, almost imperceptible transformation could occur in the profound darkness. This is the iron star hypothesis, a speculative vision of the very last macroscopic objects that could ever exist. Trillions upon trillions of years from now, the universe is a thin, cold soup of subatomic particles and radiation, the final remnants of all the protons that have decayed. Within this near-perfect vacuum, the nuclei of iron atoms drift, stable and nearly eternal. Iron holds a unique place in the cosmos as it has the most tightly bound atomic nucleus. This makes it the ultimate ash of nuclear reactions, the end point of stellar fusion. In this ultimate endgame, these iron nuclei are drawn together, not by fusion, but by the faintest whisper of gravity. They would accumulate over timescales that make the age of the universe seem like a single heartbeat. Through a bizarre quantum mechanical process known as quantum tunneling, these nuclei could theoretically fuse into larger and larger chunks of cold iron, bypassing the need for the immense heat and pressure of a star. Imagine a snowball forming in a blizzard, but where each snowflake drifts together over eons and the ball grows not by collision, but by simply phasing through the energy barriers that would normally keep them apart. The result would be a cold, dark sphere of pure iron, slowly growing in the absolute blackness. These would not be stars as we know them, radiating light and heat. They would be inert, black lumps, the final monuments to matter itself. An iron star with the mass of our Sun might take 10 to the 1500 years to form, a number so incomprehensibly vast it has no physical analogy. These objects would be the last things with substance, the final islands in a sea of fading radiation. But their existence, too, is fleeting. Even iron stars are not immune to the relentless tide of proton decay. The iron nuclei themselves will eventually, over even longer timescales, disintegrate into lighter particles and energy. The last solid object in the cosmos will, atom by atom, quietly return to the void. The iron star represents the ultimate persistence of structure, a final, defiant whisper of order in a universe destined for perfect uniformity. Deep within the fabric of space-time, relics from the universe's first chaotic moments may still be waiting to unravel. These are cosmic strings, hypothetical flaws in reality, thinner than a proton but denser than a mountain range. Imagine the cosmos as a sheet of ice freezing over. As it cools and solidifies, cracks can form within its structure. Cosmic strings are like these cracks, but in the very dimensions of space and time, formed during the rapid phase transitions of the early universe. They are not made of matter, but are pure energy and tension, one-dimensional scars left over from creation. Stretching across billions of light years, these filaments wield gravitational forces so powerful they can warp the light from distant galaxies, creating double images in the sky. For most of cosmic history, they drift silently, their immense mass barely disturbing the expansion around them, but their stability is not guaranteed. A cosmic string can develop kinks, or two strings might cross and reconnect, forming a closed loop. When this happens, a cataclysm occurs. The loop oscillates wildly, and under its own immense tension it can snap. The energy stored within a single cosmic string loop is staggering, comparable to the total energy of a star like our Sun. When it breaks, this energy is not released as an explosion we would recognize. Instead, it erupts as a titanic burst of gravitational waves, ripples in spacetime that shake the very foundations of the cosmos. In the universe's final era, long after the last stars have died, such an event would be a brief, violent storm in an otherwise eternal calm. A snapping string would send a powerful shockwave of gravity through the void, ringing the universe like a bell. While it would not reignite the cosmos, it would be one of the last grand, structured events to occur, a final, fleeting reminder of the violent forces that once shaped everything. Could these ancient defects, hidden in the darkness, be the last things to stir the fabric of reality before silence claims it all? Phantom energy is the most terrifying incarnation of the dark force pushing our universe apart. Unlike the steady dark energy we currently observe, phantom energy is defined by a specific and bizarre property. Its negative pressure actually grows stronger over time. Think of it as an unstoppable cosmic engine that becomes more powerful the more space it creates, a runaway reaction with no off switch. This self-amplifying push would not just accelerate the expansion of the universe, it would send it into an exponential frenzy. The timeline for destruction under phantom energy is shockingly finite. Instead of a slow decline over trillions of years, this scenario could see the complete disintegration of the cosmos in as little as 22 billion years from now, a mere blink on the cosmic scale. The end would begin with the largest structures. The gravitational glue holding superclusters of galaxies together would be the first to snap. These vast cosmic metropolises would be flung into the ever-widening emptiness, their connections severed forever. Next, the phantom force would turn its attention to the galaxies themselves. The majestic spiral of the Milky Way, held together by the collective gravity of its hundreds of billions of stars, would be systematically shredded. Our Sun and every other star would be torn from their galactic orbits, cast adrift as lonely orphans in a rapidly darkening sky, but the horror is only beginning. As phantom energy continues to intensify, it would next dismantle our solar system. The Sun's gravitational hold on Earth and the other planets would be completely overwhelmed. Our world would be ripped from its familiar orbit, sent careening into the interstellar void. Then, the phantom energy would do something that even the most violent cosmic events cannot achieve. It would turn inward, attacking the very fabric of reality. The force binding atoms into molecules would be defeated. The nuclear forces holding atomic nuclei together would be overcome. In the final, unimaginable moments, every single atom in the universe would be violently torn apart from the inside. Every proton, every neutron, every electron would be flung away from every other particle, moving so fast they could never interact again. The universe would end not with a collapse or a freeze, but with a fundamental and instantaneous dissolution of spacetime itself. The cosmos would be reduced to a state of absolute nothingness, a perfect and eternal void where not even the potential for structure remained. What kind of physics could possibly unleash such an absolute and final end to everything? The violent collapse of a big crunch may not be the only path to a cosmic rebirth. A newer, more refined vision of the cyclic universe is emerging, one where the mysterious force of dark energy is not an obstacle to renewal, but its essential catalyst. In this elegant model, dark energy does not intensify into a phantom force that rips everything apart. Instead, it acts as a cosmic moderator, gently guiding the universe through its life cycle. After driving a long period of accelerated expansion, dark energy's influence would gradually wane. The frantic push that isolated galaxies would slowly diminish, allowing gravity's relentless pull to once again take the lead. The expansion of the universe would coast to a gentle halt, not with a sudden jolt but with a cosmic sigh. This is not a catastrophic reversal, but a smooth, natural transition from an era of stretching to an era of contraction. The universe begins to flow back together, not in a chaotic, structure-shattering collapse, but in a controlled and steady gathering. This process meticulously avoids the formation of a destructive singularity, the point of infinite density that defines both the Big Bang and the classic Big Crunch. Instead of crushing all of reality into a single hot point, the contraction phase smoothly culminates in a cosmic bounce. Think of it not as a car crash, but as a perfectly executed trampoline jump. The universe reaches a state of maximum but finite density and temperature, and then rebounds in a new Big Bang. Our entire cosmic history becomes one chapter in an endless, breathing cycle of expansion and contraction. In this view, the dark energy we measure today is not a herald of a cold, lonely end, but the very mechanism that ensures the universe can reset itself, granting reality a form of immortality through perpetual renewal. This paradox strikes at the very heart of physics, challenging our understanding of reality itself. The black hole information paradox begins with a seemingly simple question. When an object falls into a black hole, what happens to all the information that describes it? Every particle, every atom, every quantum state that made up that object contains information, a unique identity. According to the classical rules of general relativity, that information is permanently lost behind the event horizon, irretrievably crushed into the singularity. The black hole itself, according to Stephen Hawking's early work, only radiates away a featureless, random heat known as Hawking radiation. This radiation carries no information about what fell in. It is a thermal blur, a cosmic eraser. This creates a fundamental conflict with the bedrock principle of quantum mechanics, which states that information can never be truly destroyed. It can be scrambled, hidden, or transformed, but it must, in principle, be recoverable. So, where does the information go? Is the universe fundamentally forgetful, erasing the history of everything that crosses a black hole's threshold? Or is our physics profoundly incomplete? One compelling resolution suggests that the information is not lost at all. It is preserved, but in a form we can barely comprehend. The information about every book, every star, every person that has ever fallen into a black hole could be encoded on its two-dimensional event horizon, the surface from which nothing can escape. This is the holographic principle in action, where a three-dimensional object's information is stored on a two-dimensional surface. As the black hole evaporates via Hawking radiation, this information is slowly and subtly imprinted onto the escaping radiation. It is not lost, merely translated into an incredibly complex and scrambled code. The radiation is not random after all. It is an encrypted message detailing everything the black hole ever consumed. In the universe's final era, as the last black holes evaporate in brilliant flashes, all the information they ever contained would be released back into the cosmos, not as recognizable objects, but as a final, fading data stream etched into the fabric of spacetime itself. This suggests that the ultimate fate of all information might be a state of perfect, eternal preservation, even as the universe itself grows cold and dark. Is everything that ever happened, from the birth of a star to a single human thought, permanently recorded in the cosmos, waiting for an interpreter that may never come? The violent beauty of colliding worlds might be the very reason we exist. Our universe could be the result of a cataclysm in a higher dimension, a cosmic car crash of unimaginable proportions. This is the theory of the ekpyrotic universe, an idea that replaces the Big Bang with a collision between two mysterious membranes, or branes for short. In this mind-bending picture, the three-dimensional space we inhabit is just one of many dimensions. Our entire universe is a single, vast brane, a dynamic surface floating within a higher dimensional expanse. Parallel to us, separated by an unseen gap, floats another brane, another complete reality. Under their own attraction, these two titanic membranes can drift toward one another. When they finally meet, the collision is not a destructive impact like two planets smashing together. Instead, it unleashes an immense amount of energy, flooding our brain with heat and matter, and igniting the expansion we now call the Big Bang. Our cosmic beginning was not a singularity, but a rendezvous. The ultimate fate of such a universe is tied directly to the behavior of these branes. In one possible ending, the collision was a one-time event. The two branes struck, created our cosmos, and then drifted apart forever, doomed to an eternal and lonely separation. Our universe would then follow its own isolated path, likely toward a cold heat death, utterly alone in the higher dimensional bulk. But a far more dramatic and cyclical finale is also possible. The two branes might be bound in an eternal, rhythmic dance. After the collision that birthed our cosmos, they rebound and move apart. But their mutual attraction eventually pulls them back together, setting the stage for another cataclysmic impact. Each collision is a new Big Bang, a rebirth of a universe from the ashes of the previous one. In this view, the cosmos is not bouncing from a crunch, but from a brane collision, a cycle of creation and destruction playing out across dimensions we cannot perceive. The expansion we see today, the afterglow of that last great meeting, could one day reverse as the branes begin their slow, fatal approach for the next cosmic reset. Are we living in the aftermath of one collision, quietly awaiting the next universe-shattering embrace from a dimension we cannot see? This delicate balance of cosmic forces rests on a number so precise it defies all logic. The cosmological constant, which we measure as the strength of dark energy, is not just a random value. It is incredibly small, yet crucially not zero. Its observed value is around 120 orders of magnitude weaker than what our most fundamental theories of particle physics predict it should be. To grasp this staggering mismatch, imagine calculating the weight of every mountain, ocean, and planet in the entire observable universe. Now compare that to the weight of a single solitary electron. The difference between our theoretical prediction and the observed reality of dark energy is 1,000,000 trillion times larger than that. This is not a small error. It is the greatest discrepancy between theory and observation in the entire history of science. Why is the dark energy driving the fate of the cosmos so unfathomably weak? This is the cosmological constant problem, and solving it is the master key to unlocking the universe's ultimate destiny. The value of this constant is what determines whether the cosmos will end in a freeze, a rip, or a bounce. If it were even slightly larger, the repulsive force would have been so powerful in the early universe that galaxies and stars could never have formed. We would not be here to ponder it. If it were zero, the universe would still expand, but gravity would constantly slow it down, leaving the door open for a potential big crunch. The fact that it has this specific, tiny, non-zero value is what allows for a universe that is both structured and accelerating. But we have no fundamental explanation for why it has this value. Is it simply a random, brute fact of our particular universe, a lucky draw in a cosmic lottery of multiverses? Or is there a deep, underlying physical principle, a law we have not yet discovered, that forces it to be this way? The answer will tell us if our universe is headed for a cold, lonely eternity, or if this expansion is merely the prelude to a dramatic and fiery rebirth. The fine-tuning of the cosmological constant is a mystery that points to a deeper truth. Our current laws of physics are incomplete. To truly understand the universe's final moments, especially in the extreme realms of black hole singularities or the Big Bang itself, we require a theory that can do the impossible, unite the very large with the very small. This is the quest for a theory of quantum gravity. General relativity masterfully describes the cosmos on a grand scale, the warping of space-time that creates gravity. Quantum mechanics with equal brilliance governs the bizarre probabilistic world of atoms and particles. Yet these two pillars of modern physics are fundamentally incompatible. When their equations are forced to meet, such as at the center of a black hole, the math breaks down completely, producing nonsensical answers like infinities. A complete theory of quantum gravity would rewrite the rules for these ultimate extremes, telling us what truly happens when reality is compressed to a point of infinite density. Current candidates offer wildly different visions for the end. String theory, for instance, suggests that the fundamental constituents of reality are not point-like particles, but incredibly tiny, vibrating strings. In this framework, the concept of a singularity might be smoothed away, replaced by a dynamic tangle of strings that prevents the true infinity. This could mean the Big Crunch is not an end, but a transition, a bounce into a new universe as we saw in cyclic models. Another compelling candidate, loop quantum gravity, proposes that space itself is not a smooth continuum, but is woven from a fabric of tiny, discrete loops. Think of spacetime not as a blank sheet of paper, but as a fine mesh. This mesh has a fundamental graininess, a smallest possible unit of space. In this view, matter cannot be compressed into an infinitely small point because it runs into this fundamental pixelation of reality. A collapsing universe would therefore reach a maximum density and then bounce back, again avoiding a final singularity. The ultimate fate of the cosmos hinges on which, if any, of these theories is correct. Will the end be a violent collapse into a singularity that erases the laws of physics, or a graceful rebound powered by the quantum nature of spacetime itself? The answer is written in a language we have not yet fully learned to read. Perhaps the universe is not a machine, but a living entity. This is the core of a radical perspective that reinterprets cosmic evolution as a biological life cycle, where the forces of nature are not blind mechanics, but the metabolic processes of a single, vast organism. Panpsychism, an ancient philosophy now finding echoes in modern science, proposes that consciousness is not an emergent property of complex brains, but a fundamental feature of the universe as basic as mass or charge. In this view, every particle, from a speck of dust to a distant quasar, possesses a tiny, elemental spark of subjective experience. These countless micro-consciousnesses combine and interact, creating the complex tapestry of reality. The cosmos itself, as a whole, could be a unified conscious mind born in the fire of the Big Bang. Its expansion and cooling are not a slow death, but a process of growth and maturation. The formation of galaxies and stars would be like the development of organs and circulatory systems in a developing body. Dark energy, then, might not be a force of destruction, but a necessary hormone driving a cosmic puberty, a vital growth spurt pushing the universe toward its next stage of development. The ultimate fate of such a living universe would be profoundly different from a mere heat death. Instead of a cold, silent end, the cosmos might be progressing toward a kind of cosmic adulthood or even a form of reproduction. The mysterious phenomenon of inflation in the early universe, which saw space expand faster than light, could be seen as a cosmic cell division, with our entire observable universe being just one offspring of a greater meta-reality. Perhaps the accelerated expansion we see today is preparing the cosmos for a similar event, a great parting where new universes bud off from our own, carrying with them the fundamental consciousness that defines existence. Or the final state of maximum entropy could be reinterpreted. It would not be a graveyard, but a state of rest, a cosmic sleep or hibernation. In this deep, timeless slumber, the universal mind would dream, processing all the information and experiences of its long life before perhaps gathering the energy for a new awakening, a new cycle of cosmic life. This idea transforms the universe from a cold, indifferent place into a being with a purpose and a destiny, a story that is still being written. Are we merely temporary cells within this vast cosmic body, our brief lives contributing in some small way to the thoughts of a mind whose scale we cannot fathom? Our journey toward the final silence unfolds over timescales that dwarf human comprehension. The first major milestone arrives roughly 100 trillion years from now. This is the stellar era's final curtain call, when the very last stars in the universe exhaust their fuel. These final sentinels are small, cool red dwarfs, stars so frugal they have burned for trillions of years. One by one, they too will flicker out, cooling into black dwarfs, cold spheres of degenerate matter. The cosmos, once ablaze with light, becomes a permanent night. For an almost endless period after this, the universe is a dark graveyard. The only objects of substance are the remnants of dead stars, white dwarfs and neutron stars, and the voracious black holes. But even these are not eternal. Over the next 10 to the 34th years, a process of profound transformation begins. The protons and neutrons that constitute all matter are predicted to decay. Every piece of solid matter that was not already consumed by a black hole, every planet, every asteroid, every white dwarf, will slowly and silently dissolve into a shower of radiation. The universe transitions from a collection of solid objects to a thin, expanding sea of light particles. Yet even this sea is not the end. The black holes remain, the final monuments to gravity. Their evaporation is an achingly slow process. A black hole with the mass of our Sun will take 10 to the 67 years to vanish. The supermassive black holes at the centers of long-dead galaxies will persist for far longer, up to 10 to the 100 years. Their final moments are not slow fades, but brilliant, violent flashes of gamma rays as they release their final burst of energy. When the last black hole blinks out of existence, the universe enters its most barren phase. All that remains is a dilute, ever-cooling soup of photons, neutrinos, and the elusive particles of dark matter, all spreading farther and farther apart in the relentless expansion. The temperature approaches absolute zero, a fraction of a degree above the point where all motion ceases. This is the era of eternal darkness, a state of maximum entropy where no energy differences remain to power any process. Time itself becomes meaningless as there are no longer any events or changes to mark its passage. The cosmos reaches a final, unchanging equilibrium, a silent and static state that will persist forever. The silence of a heat death is almost peaceful compared to the absolute erasure promised by vacuum decay. This quantum doomsday, often called the Big Slurp, is not a force from outside our universe, but a fatal instability woven into the very fabric of space. Our reality rests in a state known as a false vacuum, a precarious perch of apparent stability that is not the true lowest energy state. It is as if the entire cosmos is a magnificent frozen lake, but the ice beneath our feet is only an inch thick, with a bottomless, dark ocean lurking below. All it would take is a single, random quantum event anywhere in the universe to break through that fragile surface. That event would nucleate a bubble of true vacuum. This bubble would not be empty, but a region where the fundamental laws of physics are instantly and irrevocably rewritten. The strength of the nuclear forces, the mass of an electron, the very rules that allow atoms to bind together, would be replaced by an alien set of constants. The wall of this bubble would expand in all directions at the speed of light, a sphere of ultimate transformation. You would not see it coming. There would be no flash of light, no shockwave of sound. The moment the bubble's boundary touched your location, the laws of physics that constitute your existence would simply cease to apply. Your atoms would disintegrate, not in an explosion, but in a silent, instantaneous unraveling. The Earth, the Sun, the galaxy, all would be erased from the inside out, their structures incompatible with the new reality rushing outward. This wave of annihilation would be the ultimate speed limit of destruction, converting everything in its path into a new, barren state of existence where nothing we recognize could ever form again. The universe we know would be overwritten, not with fire or ice, but with a quiet, absolute, and final click of a cosmic reset button. Perhaps the ultimate reality is not physical at all, but a grand and immutable mathematical truth. The mathematical universe hypothesis proposes a breathtakingly simple yet profound idea. Our cosmos, with all its galaxies, forces, and conscious beings, is not just described by mathematics. It is mathematics. Every object, every event, every law of physics is simply a specific structure within a vast, abstract mathematical system. In this view, you and everything you perceive are not made of matter in the traditional sense, but are patterns and relationships within an eternal mathematical landscape. This leads to a radical rethinking of what an end to the universe could even mean. If the universe is a mathematical structure, then its fate is not a physical event like a freeze or a rip, but a logical conclusion. The structure may simply have a finite set of states or a final configuration. Reaching that final state would be like a computer program finishing its calculation or a song reaching its last note. The structure is complete and the cosmic story is over, but there is another, even more mind-bending possibility. Perhaps the mathematical structure is infinite and eternal, existing outside of time in a so-called Platonic realm. What we experience as the flow of time from the Big Bang to a potential heat death is merely our limited, sequential journey through this timeless, unchanging truth. We are like readers moving through a book page by page, believing the story is unfolding. Yet the entire book, from the first word to the last, already exists completely and eternally. From this God's eye view, there is no true beginning or end. The heat death, the big crunch, or any other cosmic finale is just a particular chapter, a fixed part of the eternal whole. The universe does not end. Our conscious traversal of its data simply reaches a terminal point. This idea forces us to ask a haunting question. Are we living in a physical reality that is destined to die, or are we temporary manifestations of an eternal, abstract equation, briefly experiencing one small part of its infinite and timeless truth? Our own consciousness might not be a passive bystander to the cosmos, but an active participant in its final act. This is the startling implication of observer-driven fate, a theory rooted in the strange rules of quantum mechanics. At the tiniest scales, particles exist in a blur of possibilities, a superposition of states until the moment they are measured. The simple act of observation seems to force this quantum fog to collapse into a single, definite reality. For a single electron, this is profound enough, but what if this principle scales up to the entire universe? Some speculative interpretations suggest that consciousness itself, the act of observing and measuring, is what solidifies reality from a sea of potential. The universe we see is the one being continuously observed by countless conscious beings within it. So what happens when consciousness itself begins to fade? In the distant future, as stars die and planets grow cold, the number of observers will dwindle to zero, with no one left to look at the moon, to measure the light from a distant quasar, or to simply be aware, does the universe remain solid and real? It might revert to a state of pure potential, a ghostly haze of what-ifs where every possible outcome exists at once, but none are actual. The final state of the cosmos would not be a physical event like a freeze or a rip, but a quiet withdrawal of attention. It would be the ultimate dream from which no one wakes up. Alternatively, the last conscious being could hold a bizarre and lonely power. In its final moments, as it gazes out at a dying cosmos, its own observation could determine the nature of that end. Would it see a gentle fade to black or a brilliant final flash? The universe's finale would become a deeply personal experience, its grand fate intertwined with the last flicker of awareness within it. Are we, through the simple act of looking at the stars, not just understanding the universe, but in some small way helping to bring it into being? A profound loneliness awaits every particle in the cosmos. This is the era of asymptotic silence, a state beyond even the cold emptiness of heat death. The universe's expansion does not merely continue, it accelerates without end, stretching the very fabric of spacetime to its ultimate limits. Over timescales that make the evaporation of black holes seem brief, this relentless stretching drives the cosmos toward a final, unbreakable solitude. The distance between any two surviving particles increases at a rate that forever outpaces the speed of light. This means that no photon, no signal, no fragment of information can ever bridge the growing void. Each elementary particle, each faint ripple of energy, becomes an island universe unto itself, isolated for eternity. Imagine the last photon, emitted from the final flash of a dying black hole trillions of years ago, traveling through an ever more perfect vacuum. Ahead of it, the space it aims to cross is stretching faster than it can move. It is like a runner on a treadmill that speeds up infinitely, destined never to reach the edge. That photon will journey forever, its light never to be seen by any other entity. In this ultimate future, the cosmic horizon closes in around every point until each is trapped in its own private cosmos. There are no more events, no more interactions, not even the potential for them. The universe does not just grow dark and cold, it becomes fundamentally unknowable to itself. Every connection is severed, every history is sealed away, and the concept of a shared reality simply vanishes. This is not an end of things, but an end of relationships, a final and absolute silence where even the memory of light is lost. The very expansion that promises an eternal, silent end might instead be the engine of a new creation. Roger Penrose's conformal cyclic cosmology offers a vision of the universe not as a single story with a final page, but as an endless series of volumes where the conclusion of one seamlessly becomes the prologue of the next. This theory sidesteps the need for a violent big crunch entirely, proposing a far more elegant and subtle transition. In the unimaginably distant future, our universe will have reached a state of near-perfect equilibrium. All matter has decayed into radiation, black holes have evaporated, and the cosmos is a vast, cold, and nearly featureless sea of massless particles like photons and gravitons. In this profoundly simple state, something remarkable happens. The universe loses all sense of scale. A single photon traveling across this infinite void experiences no meaningful distance or time because there are no massive objects left to provide a reference point. In this state, the cosmos can be mathematically rescaled or conformally transformed. Think of it like taking an endless, flat, empty plane and shrinking it down to the size of a single, hot, dense point. Through this cosmic rescaling, the infinite future of one universe is geometrically reborn as the high-energy, high-temperature singularity of the next Big Bang. The silent, cold, and vastly expanded end of our cosmos becomes the hot, dense, and infinitely small beginning of a new one. The radiation and energy from the previous eon provide the raw material for the next cycle of creation. According to Penrose, the evidence for this might even be imprinted in our own universe's cosmic microwave background, in the form of faint, circular patterns, the gravitational echoes of supermassive black hole collisions from the eon that came before ours. This is not a cycle of collapse and explosion, but a cycle of transformation where the universe forgets its size and is reborn from its own faded remains. Could the ultimate fate of everything be to simply start over again and again forever? Even as the cosmos drifts toward its final state, life and intelligence may refuse to surrender to the darkness. The ultimate fate of consciousness could be a grand technological rebellion against the dying of the light. Imagine civilizations so advanced they have mastered the very fabric of reality, harnessing the energy of entire galaxies to power their survival. In the era of decaying stars, such intelligences might not live on planets at all, but within vast, efficient structures orbiting the last stable energy sources like black holes. They could become digital beings, uploading their minds into robust, distributed computer networks that require only minimal power to sustain a single, collective consciousness. This hive mind could then enter a state of near-suspended animation, processing one thought per century to conserve energy, waiting patiently through the eons for a rare, usable energy fluctuation in the cold void. Their ultimate goal would be to cheat the heat death itself. Some theories suggest they might learn to create baby universes in the laboratory, manipulating quantum fields to spark new Big Bangs, and then migrating their entire consciousness into these nascent realities. They would become cosmic gardeners, planting seeds of new creation, and then stepping through the doorway into a younger, warmer cosmos. Alternatively, they might choose to transcend physics entirely, converting themselves into pure information encoded in the fabric of space-time, existing as eternal patterns in the very geometry of the universe long after the last star has faded. This transforms the concept of an end from a finality into a transition. If the last act of intelligence is to create a new universe, then the death of one cosmos becomes the birthplace of the next. The cycle of life and consciousness could become eternal, a self-perpetuating flame passed from one dying reality to the next. Does the universe truly end if a form of awareness finds a way to witness the final silence and then decide to simply start the story over again? Every force that governs our reality is a temporary expression of a deeper, singular truth. In the universe's first fleeting moments, all of nature's forces were one, a perfect symmetry where gravity, electromagnetism, and the nuclear forces were indistinguishable. As the cosmos expanded and cooled, this perfect unity shattered, freezing into the four separate forces we recognize today. This fracturing created the world we know, enabling the complex structures of atoms, molecules, and life itself. But what if the universe's ultimate fate is to return to that primordial state of perfect harmony? In the final, cold emptiness of the heat death, a profound reunification could occur. With all matter decayed and all energy uniformly spread, the conditions that broke the symmetry would cease to exist. The temperature would approach absolute zero, and in that profound chill, the distinctions between the forces might simply fade away. Gravity, the sculptor of galaxies, would no longer have massive objects to bend space around. The strong nuclear force which binds atomic nuclei would have no protons or neutrons left to hold together. The weak force responsible for radioactive decay would have no particles left to transform. Electromagnetism would have no charged particles to push or pull. In this state of absolute equilibrium, the forces would have nothing left to do. Their separate identities, born from the fiery chaos of the beginning, would become irrelevant. They would effectively merge back into a single, unified field, a state of perfect symmetry and stability. This final state would not be one of destruction, but of resolution. The universe would achieve a kind of eternal, silent peace, its entire tumultuous history culminating in a return to the simplest and most elegant state imaginable. It is the ultimate cosmic circle, closing not with a bang, but with the quiet click of a perfect and final unity. From the profound silence of a unified field to the defiant spark of new universes created by intelligence itself, our journey through 30 cosmic finales reveals a spectrum of endings as vast as the cosmos. We have wandered from the cold, quiet fade of the Big Freeze to the violent dissolution of the Big Rip, and from the cyclical rebirth of a bouncing cosmos to the random, fleeting consciousness of a Boltzmann brain. Each theory, whether grounded in established physics or soaring on the wings of speculation, offers a different lens through which to view our ultimate destiny. The sheer range of possibilities is both humbling and awe-inspiring, forcing us to confront our place in a universe that might be eternal, temporary, cyclical, or even conscious. These are not just abstract scientific concepts, they are the potential final chapters to the grandest story ever told, the story of everything that exists. So we turn this final question over to you. Which of these cosmic fates feels the most profound, the most terrifying, or the most beautiful? Is it the serene eternity of a heat death, the dramatic reset of a big crunch, or the possibility that our own awareness might play a role in the final act? Share your thoughts in the comments below and let us know which ending you believe awaits us all.